Hi everyone, I'm Amir. I'm leading the product at Agri-Light, and we've developed a unique agrivoltaic solution that helps farmers increase their crop yields and generate solar power on the same land. Let me explain the what a bit better. Please meet farmer Joe. Joe is producing about 5 tons of fruit every year. Using the Agri-Light solution, Joe is now producing 6 tons of fruit, which are 20% more, and with better fruit quality, better shape, and better color. And Joe has now another revenue stream by generating solar power on his own land. Now, before jumping into the how, let's discuss some of the world's most acute problems. The agriculture sector of today is facing 3 main challenges. We need to produce much more food for an ever-increasing global population, but on decreasing arable land, which means also less land for agriculture and less land for traditional solar projects, and of course, with increasing climate change impacts that are just getting worse and cause a lot of pain for many, many farmers out there. Now, what are the main problems within the agrivoltaic market in terms of technology? The main problem with sun trackers, which is the most common used technology today, is when tracking the sun, it produces the maximum amount of power, but it casts shade over the crops, which damage photosynthesis, as we can see in the graphics here. Now, on the other side, if we want to benefit the crop, benefit the photosynthesis, we need to align these panels to be parallel to the sun to allow more sunlight over the crop. But then we damage the power generation capabilities. Bottom line, we need to choose during most operation time of these solutions in between the two, if you want to prefer the power generation or if you want to prefer the plant, the photosynthesis. At Agri-Light, we've managed to solve this problem. We do them both and at the same time. We've developed and patented an advanced agrivoltaic solution that is based on 2 main elements. The first is a dual hybrid axis, which we can move the panels that are placed above the tree lines from side to side on a horizontal axis, and this is integrated with tilt movement, like sun trackers, to help us control the shade and light and place it exactly where we want. Now, for example, if you want to place the shade on top of the crop because it's too hot, or in between the crops because it's less hot, we can do that and still be able to mount the same amount of power in both positions. Now, this is all based on mathematical algorithms, on sun models, and of course on plant needs. And understanding plant needs in real time is our biggest R&D effort in the coming years. We want not only to take the measurements, but also to analyze the parameters and the different interactions between the many, many parameters to be able to develop the most ideal stress and photosynthesis models per each one of our target crop. Now, as for testing our solution, we have won 10 different pilot tenders by the Israeli ministry, testing different crops all across the country, from mangoes in the south to avocados in the north. And also, 6 months ago, we have won a grant by the Israeli Innovation Authority. And in these days, we're completing our first pilot in the Negev desert, testing 8 different wine grapes, as we can see in both of these pictures. And last month, we also have signed a new contract in Spain, testing our solution over olive trees and wine grapes in the Valencia region. Now, the business opportunity is quite promising, with an estimated growth of more than $10 billion in the next 10 years and with a CAGR of above 10%. Now, how do we plan to make money of it? So most of our business model and our revenue is based on direct technology sales to the agrivoltaic developers, which are usually the engineering companies and the energy firms. And we also combine it, of course, with our SaaS model for the extensive use of our mobile app and smart predictive tools. So we look to raise another $2 million to complete our seed round and to establish 2 more strategic pilots that will be also demonstration sites in our key markets, focusing mainly on the US and Europe, and of course, continue the development of our R&D smart agrivoltaic models. Last but not least, we always thrive for new connections with investors and with partners. So don't hesitate to reach out, and thank you very much.
Hey. Adi from E44 Ventures. Your structure, how much each increase the capex per orchard?
So we try to be, for now, our target to be same as the others, about $1,000 to $1,200 per kilowatt. But we are in the process of minimizing it towards 900, maybe 850 per kilowatt installed.
And compared to land PV with trackers, what is your efficiency? So
our coverage is about 50%, which is a bit more than traditional, not traditional, but smart trackers. But the main thing is that we can generate both energy and increase the crop at the same time. So eventually, the solar companies will be happier than us because, first of all, their customer, their farmer will be happier because he gets better results. And they can get better results because they produce more energy at the same time rather than just normal trackers that need to prioritize sometimes the farmers at the same time.
I have a few more, but I see Shai is waiting.
I saw that some of the pilots are vineyards and mangoes and other that require some heavy equipment, agriculture equipment to operate in the field.
Right.
How do you cope with that?
Yeah, so it's a good question. We've designed our system so we can move tractors in between the rows. It's not an easy thing. For example, for now, we can't focus on just normal grapes, but we're aiming to wine grapes because they do it by hand. So we're now designing a new solution to cope with that. But in most of the orchard and vineyards, we can cope with no problem.
Thank you, Amir.
Thank you very much.